Hi everyone, I am Ashok Kumar, Professor of Mechanical Engineering, Nanda Engineering College, E-Road. Today I am going to give the overview of projection of points. In last video, I given a brief introduction about the orthographic projections and I also discussed elaborately about the projection of points. So what is orthographic projections? So before that we will see some terminologies. This is called plane and this is also called plane. The plane is the entity over which the projection will be drawn. So as the orientation of this plane is vertical, so this is called vertical plane. As the orientation of this plane is called horizontal, so this plane is called horizontal plane. So the vertical plane is used to project the front view. The horizontal plane is used to project the top view. In this similar manner, there are some another plane called profile plane. So the profile plane is used to draw the or project the side views. Okay. So so here we will just discuss about the front view and top view. So before that, what is the orthographic projection? So here the position of the observer to draw the front view is here. Okay. The rays coming out from the observer's eyes are perpendicular to the plane on which it is projected. So here the position of the observer is to view the object in the front view. So the front view will be projected on vertical plane. So here the rays coming out from the observer's eyes are perpendicular to the vertical plane. To draw the top view, the observer's position is here. The top view will be projected on horizontal plane. So the rays coming out from the observer's eyes are perpendicular to the horizontal plane. So in general, in orthographic projection, the rays coming out from the observer's eyes are perpendicular to the plane on which it is projected. So these are the quadrant. So this may be taken as, for example, take this one. This is the quadrant. This is the first quadrant, second and third, and this one is called fourth quadrant. So for our convenience, we take this is the HP1, horizontal plane 1, and this is the horizontal plane 2, this is the vertical plane 1, and then vertical plane 2. So entire this system is called quadrant. So this is the first quadrant, second, third, and fourth quadrant. If the object is placed in the first quadrant, the front view will be projected over the vertical plane, the top view will be projected in horizontal plane 1. If the object is placed in the second quadrant, the front view will be projected in vertical plane 1, the top will be projected in horizontal plane 2. If the object is placed in the third quadrant, the front view will be projected in VP plane, vertical plane 2, and the top view will be projected in the horizontal plane 2. If the object is placed in the fourth quadrant, the front view will be projected in the vertical plane 2, the top view will be projected over the horizontal plane 1. Okay, after we project the front view over the vertical plane and top view over the horizontal plane, we must rotate the horizontal plane. Whether it is the horizontal plane 1 or horizontal plane 2, we have to rotate the horizontal plane 90 degree in clockwise direction. So if the object is placed in either first or fourth quadrant, the top view will be projected over the HP1. So after we project the top view over the horizontal plane 1, we have to rotate the horizontal plane 90 degree in clockwise direction. So the top view will come below this intersection of VP and HP. So this is called XY. XY is nothing but a reference axis, that is nothing but intersection of vertical plane and horizontal plane. It is the intersection of VP1 and HP1 or VP2 and HP2. For both it is the intersection axis. So similarly, if the object is placed in either second or third quadrant, top view will be projected over the HP2 only. After we projected the top view over the horizontal plane 2, we have to rotate the horizontal plane 90 degree in clockwise direction only. If we rotate in such a manner, the top view will go above the XY reference axis. So if the object is placed either in first or fourth quadrant, the top view will come below the XY reference axis. If the object is placed in either second or third quadrant, the top view will be drawn above the reference axis. Okay. Next, to describe the location of the point to which the projection is to be made, they will use the terminology like this. So the one reference is given with respect to HP, another reference of location will be given with respect to VP. So okay, first we will consider about the location of the specific description of location of the object with respect to HP. To describe the location of the object to be placed either in first or second quadrant, it will be used above HP. The point A or B is some distance above HP. Above HP means the object may be placed either in first or second quadrant. On the other hand, if the object is placed some distance below HP means the object may be placed either in fourth quadrant or in third quadrant. The next reference for the description of location is with respect to VP. For example, to describe the location of the object which is placed in either first or fourth quadrant, the term to be used is the point A is some distance in front of VP, because the location or position of the observer is always here. So with respect to him, the point A is some distance in front of VP is given, then the object is placed either in the first quadrant in front of VP is given, the object is placed in fourth quadrant also. So it is either in first or fourth quadrant. The term is the point X or Y is some distance in front of VP. To describe the location of the object to be placed in either second or third quadrant, the description is a description as the point A or B is some distance behind the VP. So they used the term behind the VP. Behind the VP means the particle may be placed either in second or third quadrant. Okay, we will see some examples over here. Here the point F is placed on VP. So placed on VP means the particle may be placed in the intersection of first or second quadrant or third or fourth quadrant. So the object may be placed according to this first statement. The point F is placed somewhere in the vertical plane. The next one is 25 mm. The point is 25 mm above HP. 25 mm above HP means, so this is the location. It is not in the intersection of third and fourth quadrant. It is the intersection of first and second quadrant. So this is the point F, which is exactly lying over the HP, and the point is 25 mm above HP. So to draw the front view, as a projection of the front view, we can able to see the distance between the HP and the point. So what is the location of the point with respect to HP? 25 mm above HP. So the F dash is the notation to denote the front view of the given point capital F, so which is 25 mm above HP. So this is the 25 mm. Next, the point is on the VP. On the VP means while we view the object, the point F, it will be exactly fall over the XY reference axis itself. So this is the top view of the given point. So the point G is on HP and VP. So the point G is lying on the point G, HP and VP. So the point G is exactly placed at the intersection of intersection of HP and VP. So there is no distance between the point G and HP, and similarly there is no gap between the point G and VP. So the front view is lying in the XY reference axis itself. Similarly the top view is also fall on the XY reference axis itself. So this is the point for front view as well as top view. We will see another example. The point H is on HP. So somewhere here the point H is there. At the same time the point is 35 mm behind VP. So definitely the point is lying either in second or third quadrant according to this statement. According to the first statement, the object is exactly lying on the HP. So it is the particle H is at the intersection of second and third quadrant. So this is the point H which is lying on the HP, and the point H is 35 mm behind VP. So this distance is 35 mm. So to draw the front view, object is exactly placed on the HP, so its corresponding front view will be projected over the XY reference axis itself. So this is the XY reference axis, that front view will be projected exactly on the reference axis. So the front is denoted by H dash. Then next we have to draw the top view. Top view is projected on the horizontal plane itself. The distance between the XY reference axis and the top view is 35 mm. After we draw the top view, we have to rotate the horizontal plane 90 degree in the clockwise direction. If we rotate the top horizontal plane 90 degree in the clockwise direction, the top view will go above the reference axis for the 35 mm. So from here measure 35 mm. So this is the top view of the object. The distance between the top view and the XY reference axis is 35 mm. So this is the projection of the given point. Okay, so the point I, which is on VP and 20 mm below HP, just pause it and then do it. Okay, so this is the reference axis. The point I is lying on VP, so it's somewhere, the point I is placed either here or here. Next, the point is 25 mm below HP, so definitely the point I is in the intersection of, that is the VP2. It is the intersection of fourth quadrant and third quadrant. The distance between the reference axis and the point is 20 mm. So the front view we can able to see the, so the observer's position is here. The front view, in front view we can able to see the distance between the horizontal plane and the object. So here the point is 20 mm below the HP. So from the XY axis you measure the 20 mm below at the bottom side, and this is the front view. So I dash, which is 20 mm below the reference axis. In top view, the top view will be projected over the XY reference axis itself. So this is the small I. So this is the small I. So this is the projection of the given point. Okay, similarly you can do this problem also. Thank you for watching. Next video I am going to discuss about the projection of lines.